Hello there, sir. We are Group 1 from TT1L. Welcome to our presentation of Database and Cloud Security Assignment 2. For this assignment, our objective for this assignment was to migrating a traditional application to AWS. To complete this secure migration, we use Terraform for our infrastructure as code part. Let us start with our proposed secure AWS architecture. As you can see, this is our diagram here. Let's take a look. AWS architecture, let's starting with compute. We utilize the AWS ECS Fargate. This hosts our Python Flux application with auto scaling function between 2 to 10 tasks based on CPU and memory usage. It will ensuring high availability across US East A1 and US 1B ability zone. For the database, we migrate to Amazon RDS MySQL. For this instance, is deployed in private subnet with no public access. And access is strictly restricted to our ECS tasks via security groups. This can directly provide the data protection. We also can configure daily automate backups for disaster recovery. For database, we also use encryption for our RDS and S3. And for encryption, we choose ALB's ASL/TLS for all the data transmission. For the next one is networking. For our networking foundation is an Amazon VPC, which acts as our insulate network environment. Within this VPC, we have public subnet for our ALB and ECS and private subnet, especially for RDS, enforcing clean network segmentation. For the next one is our load balancer. Load balancing is handled by an application load balancer or ALB in short, which distribute traffic across our ECS tasks in different availability zones. It also handle SSL termination and intelligent level 7 routing. We configure health check every 30 seconds to ensure traffic only goes to healthy instance. For our content delivery, we use Amazon S3 to store our static content. It will configure with encryption, AES encryption, and versioning for data protection and recovery. For the next one is our security groups acting as a stateful firewalls, enforcing least privileged assets. For instance, our LB allowed HTTP and HTTPS. ECS only accept traffic from the ALB on port 5000, and our RDS only permit MySQL access from ECS and our admin instance. For the next one is our security service, which include AWS WAF version 2, which protect against common web vulnerability like the OWASP top 10 and malicious IPs with managed rule set. It also include the rate limiting configured at 2000 requests per 5 minutes window per IP. It reduce the DDoS attack. And also we implement the identity and access management in IAM. In short, we assign our specific IAM roles for the ECS task execution and task runtime, strictly adhering to the principle of least privilege. Administrative access utilize MFA for an additional layer of security. And also finally, our monitoring and logging are handled by CloudWatch. We have dashboard and alarms monitoring ECS, RDS, ALB, and WAF metrics. ECS contain logs and centralized in their own logs group for easy analysis, and SNS alerts notify us of performance and security anomalies. This will improve our incident response capability compared to traditional setup. That is my part for the introduction. I will moving on to Chi Jae Heng.
My name is Jiang, and now I will start with the Terraform, how we apply the Terraform. So basically, we will type Terraform apply at our terminal, and then we will show apply complete. And then we will have to SSH SSM to our RDS, and then to make the script. So that's all, and then I'll show our web app now. Okay, so this is our web app where it is a university directory. We can see all the lecturers detail here. And then we will have the basic functions such as sign in as a lecturer, where the lecturer can edit his or her profile here, or we can sign in as admin, where the admin can see the logs of the web app, and then also have some basic functions such as add new faculty, add new user, manage users, and also manage faculties. Okay, so now I'll start with some of the main AWS services that we use, starting from the EC2, the instance. As you can see here, the instance is running, and then also our security groups. So these are our security groups. And then moving on to the VPC. This is our VPC where it's available. And then also our subnets, our internet gateways, and our network ACLs, where we have 4 subnets. And then moving on to the S3. So this is our S3 bucket where we store all the lecturers' image inside. And then moving on to the RDS, which is our database. So it says here is available. And then next will be the CloudWatch, where we can view the logs and also the alarms. Okay, so now moving on to the IAM role login. So starting from our developer role, where we can sign in right here. So for developer, we will have some limited access. So like for example, the developer cannot view our bills. It will show access denied here. Okay, so this is just an example. Moving on to the admin login. Okay, so basically our admin will have all the access for all the services. So for example, the admin can view the bills here.
Okay, so for the testing part, we use Kali Linux, the tools within Kali Linux to test about the website. First, we run nmap to scan the ports for all open and closed ports, and we found that only port 80 is open because that's where our website hosts. We can't use HTTPS because not within the free tier, so we only have port 80. And second, we run SQL map injection, where we test whether the web app is vulnerable to SQL and XSS injection. And throughout all the tests, it says that it is secure and it can't be injected. And then thirdly, and the last one is we run a DOS attack, where we DOS the whole website, and we found out that it still has the service available after doing. So that's for my part, and thank you.